Okay, thanks Rob for the introduction, and also thank the organisers for the invitation to present today, and acknowledge that the work that I do and the fact that I can come to these things is through the financial support of the Department of Primary Industries and GRDC. Also acknowledge my co-authors, Dr Mark McLean, who's a colleague of mine at Horsham, and Andrew Milgate and Will Cuddy, who are both with New South Wales DPI. Andrew specialises in septorial diseases at Wagga Wagga, and Will Cuddy is based within the University of Sydney's RUST program. So kicking off into RUST, I think taking back to where we were looking at the review of what happened last year, and I think back to when I was presenting here a year ago, I was talking about that the expectation is that rust pressure would be lower, but even though that the rust pressure was going to be lower, we still had to take notice of managing rust in the more susceptible varieties. Now, the reason that we were saying that rust pressure would be lower in 2013 was because of the drier summer, in contrast to what we'd seen in the summers previously, particularly in 2011, where we had a lot of volunteer crops that were heavily loaded with rust. Rust can only survive from one season to the next on living plant material. So if we have a dry summer, the opportunity for the rust to carry over is much less. Therefore, the rust pressure in the coming season will be lower, and part of that is the timing of the rust coming in. And that's what we saw last year. The rust came into crops, but much later in the season. But where there were some issues, is particularly in the more susceptible varieties, where rust management was stopped in a lot of cases because the pressure was lower. But I really need to reinforce, if you're growing highly susceptible varieties, that unless the season is exceptionally dry, you do need to be managing rust in those sorts of varieties. And I think this work that Joshua Fanning, who's a colleague of mine at Horsham, did last year can help reinforce just how susceptible some of these varieties are. If you look at the green lines there, represent rust progression in a couple of resistant varieties. And what Joshua did here was he observed rust in a number of varieties on 10 occasions, so that we can see the progression of rust, and what he's looking at is the percentage of leaf area infected. And these measurements relate very strongly to yield. So if we look at Derrimut and Kara, which is what a lot of us refer to as being susceptible varieties, and you can see how the rust progressed last year in those varieties, and this is from a natural infection at Horsham. And then we can compare that to mace, and you can just see how much more susceptible that highly susceptible variety is. Our rating scale is not linear, so the difference between that resistant to a variety like Derrimut, you can see how different they are, but it's just as different again when we only move another couple of categories to mace. So why do we say that we need to be very active in the management of a variety like mace? Now, if we think about taking an approach that we would for most of our other varieties, where we'll monitor and only spray if needed, if you took that approach with mace and said, well, we're going to monitor and then apply a fungicide when needed, if we looked at it on the 7th of October, there's no rust there, so we'd say do nothing, come back in 7 days and go, well, there's rust, we better do something. And then by the time the farmer who's going to the footy that weekend gets back, and that's 2 days of wet weather, he sprays it pretty quickly, which is 5 days after that observation. And really anything that he does then is not going to change what's going to happen in the next week anyway. So you give it another 7 days, even if there was a fungicide applied, that level of infection in that crop has really got out of hand. So a variety like this, we have to have the fungicides put out ahead of us seeing rust there. So it's very important to have a proactive management. I'll just go back a moment. The other point I wanted to make here is in terms of what does this mean for yield, and in some work that we did in 2006, I think it was, to give an idea of what this means for yield if we had an early infection in these varieties, is that you're looking at, if this was a 5 tonne yield potential, you'd get 5 tonne from these varieties in the absence of fungicides. In the absence of fungicides, you get about 3 tonnes, so there's a fair bit of resistance in those varieties, and in this case, you get 1 tonne or less. So that just gives you an idea of the level of risk that is associated with those varieties. A proactive approach with fungicides does keep that under control. The other thing this data shows us is looking at, we've got 3 blue lines here, which is for 3 varieties that rated moderately resistant and moderately susceptible. When we're putting ratings on varieties, we're using 9 categories going from that resistant to very susceptible. But within each of these categories, there can be a range, and that's very well shown here, that we're seeing a difference from within the moderately resistant to moderately susceptible category. Where those varieties sit in there varies from one season to another, because the disease development interacts with the variety, interacts with the environment and the rust pressure, and it can be how much nitrogen in the crop. There's a lot of things. It's a biological system. So we're doing the best we can to give an overall idea of how that rust is going to perform. Sometimes those ratings will overlap in one season. You can see here where we've added Scout, which is rated in the next category. In this case, it's overlapping with the category below. So hopefully that helps you understand that how we are doing some of these ratings, that we do have to make decisions of where we draw a line. And then you can look at a whole range of varieties, which is reproduced in your book, to see how the different varieties perform over time, over the season. The other thing I want to do now is talk about stripe rust pathotypes, and you're all familiar that the pathotypes change over time. But since 2003, when the Western Australian pathotype first arrived in Eastern Australia, there's only been several changes that have been really significant for us, and I'm just going to take you through those and talk about the latest one of significance for Victoria. So in 2003, the Western Australian striped rust arrived in Eastern Australia. There was a new introduction to Australia in 2002. And it resulted in us re-rating lots of the varieties that were growing in terms of their response to this strain of striped rust that arrived. But at that point in time, the varieties that had the striped rust resistance gene YR17 or YR27 were rated as resistant. So they were clean to that disease. And this is the strain that is still the only one present in Western Australia. So they haven't had the changes that we've had. 2006, that strain had a mutation which enabled it to attack varieties that had the resistance gene YR17. And some of the current examples of those varieties are things like Mace, Scout, Derrimut, and there's several others. Now those varieties, if you look at a Western Australian guide, they will be rated as resistant. So you go to Western Australia, Mace is clean because they don't have a striped rust strain that it can attack it. Now over time, we saw the WA strain was the dominant one. Over time, we started to see a mix of these two strains where one site would have one strain, another site the other. So now we're at the point that the WA YR17 has become the dominant strain out there because it could attack a wider set of varieties than the WA strain. So effectively, it's increased in importance. Now in 2010, there was another change of significance in that YR17 strain, which enabled it to also attack, in addition to the YR17 gene, the YR27 gene. Now that was present in southern New South Wales. We didn't see it in Victoria until 2012, but at that point we still didn't regard it as being important. But in 2013 we had some more reports of it in Victoria. So it's increasing in frequency in Victoria, and my expectation is that over time it will become the dominant strain in Victoria. And that's what's been happening in the area from where it was first identified in southern New South Wales. Each season it's been increasing in frequency. So as a consequence, the ratings that you see in the guide now reflect that as the strain that we expect is going to be the most important. But for most varieties, that hasn't resulted in a change at all. The only ones that are of significance to in Victoria are those that contain the YR27 gene, and those varieties are things like Wagon, Ruby, Marinda, and then Livingston as well I've put in bold because Livingston has both the YR17 and YR27 resistance in it. So even though Livingston had YR17 resistance, it was still resistant to the WA YR17 strain. But it's only when that strain also acquired the ability to attack 27 that Livingston's rating has been reduced. Now not all these varieties go to being susceptible. They just become more susceptible than what they were, and Livingston's an example that was rated resistant. Now we rate it as moderately, as MRMS, because it has some other resistance genes in there as well, some adult plant genes that give it some protection as well. Another one to note is leaf rust. There was a new pathotype detected in northern New South Wales that enabled to attack some gene combinations that had provided protection in the past. Now on the whole, the varieties that has implications for is of not great significance to Victoria, but the varieties that are in the guide that are affected at this stage have a hash next to them as a warning that they are potentially more susceptible to a strain that we haven't yet seen in our region. Now, we expect that over time that strain will move from Northern Australia into our region, but at the moment we haven't re-rated varieties in light of that strain. It's not until we see that it will be important in our region, but there is a warning there so that if you're seeing a crop, maybe Naparoo, and you're seeing leaf rust in there, you see that warning there to go, well, this was probably expected. But the way we do know that what's going on is because people like yourself send rust samples either to myself or to the Australian Cereal Rust Survey, and they look at what strains of rust are out there, and that informs in terms of what varieties are prone to be susceptible and what pathotypes are out there, which we then feed back into the ratings so that the ratings can be as accurate as possible. So for 2014, I guess the situation that I see it as it is at the moment, we're coming off low levels of rust pressure at the end of 2013, going into a dry summer, so the opportunity for disease carryover is very low, which you can factor into the way that you're planning on managing rust, but very important for those very susceptible varieties, and the susceptible and very susceptible varieties that you still have a proactive plan in place to manage that. For some of the intermediate varieties, I think there's a place there to back off some of the management with a view to active monitoring, with a view to timely foliar fungicide applications if it is warranted as the season goes through. But the best strategy for controlling rust is to avoid the most susceptible varieties. Septoria triticide blotch. There was some mention of it yesterday. Now, during the 1970s, Septoria triticide was the most important foliar disease of wheat in Victoria. So in a lot of ways, it's not a new issue. What happened in the early 1980s is that some varieties with partial resistance to Septoria were released, and we'd also got away from the wetter seasons of the 1970s. That in combination put downward pressure on the inoculum, and with that partial resistance in varieties, we've had a long period of control of this disease. But in the high rainfall area for the last couple of years in our disease guide, we've been putting a warning there that Septoria levels are increasing and needs to be taken seriously. And what we've seen, particularly last year, that the levels are increasing there. And so the factors contributing to that increase in Septoria is around an intensive cereal cropping system, stubble retention, susceptible cultivars, and also ideal conditions. So symptoms of the disease is looking into the lesions, and if you can see those black fruiting bodies within the lesions that are raised above the surface, when you see those you can be pretty sure that you've got Septoria there. But if there's any concern, you can send them in the department and we can confirm that for you. So Septoria is predominantly a stubble-borne disease, so it survives from one season next on stubble. The length of survival really relates to the survival of that stubble there. If the stubble breaks down quicker, we will reduce the amount of inoculum. Early in the season, airborne spores are released from the stubble and they can spread across the district. So they're an airborne spore which has dispersal over an area. So an early sown crop that doesn't have stubble in that paddock may well get infected from a neighbouring paddock that may even be a couple of kilometres away. But once the infection establishes within the crop, all the spread occurs within that crop because it's through rain splash that the disease progresses up the plant. Now, the wetter the season is, the more rainfall, the more disease that will develop in that crop. If we get dry conditions, extended periods without leaf wetness, disease progression really slows down. Now, there was quite a significant finding by Andrew Milgate, who specialises in Septoria in Australia, and he's based at Wagga Wagga, and he looked at isolates of Septoria from the high rainfall zone of Victoria and found that there was evidence there for mutations that reduce the efficacy of triazole fungicides for the control of Septoria. So we're seeing evidence for fungicide resistance in Septoria populations in that area. And this is the first time that we have evidence for fungicide resistance in a pathogen of wheat in Australia. Now, the fungicides that are implicated at the moment are triadimifon, triadiminol, tebuconazole, propiconazole and epoxiconazole. Now, these mutations at the moment really serve as a warning. The fungicides are still effective, but they're just less effective than what they were. So we haven't lost those fungicides as yet. But the next step is that we get another change further to that, then we get into a situation where the fungicides become ineffective. So it's very important that we adopt strategies that we can use to prolong the use of these fungicides. And if we continue using the same fungicides, the same active as a single active, 2 to 3 times in a season within the same crop, we're going to lose the use of the fungicides very quickly. So it's something that those people who are advising people in those regions really need to understand what they're going to do about extending the life of fungicides. So some of the things you can do to reduce the pressure in terms of selection pressures for further resistance to develop is to use combinations of triazoles where possible. So the fungicides that are mixed, something like Tildextra, which has propiconazole and ciproconazole in there, and Impact Topguard also has those mixes there. The other thing is to not use the same active twice within the same crop. So if you're going to use epoxyconazole at growth stage 31, don't follow up with it at the second application timing. So very important, where possible, using mixes, but also rotating fungicide, the active that is used. Currently, strobes are effective, but they're a group of chemistry that develop resistance, or the fungicides develop resistance to strobes very quickly. And this is the experience with Septoria tritici in Europe and the United Kingdom, that the strobes can be lost very quickly. Currently, they have a place because we haven't seen that. And fortunately, the strobes, when they're used in combination with a triazole, hopefully they can remain effective for a period of time. The most important thing is to adopt an integrated disease management approach, so we're not relying on fungicides as our only control of Septoria. So things we need to look at: crop rotation, again because it's a stubble-borne disease, and anything that we can do that reduces the amount of inoculum or the amount of stubble there is going to reduce the amount of inoculum that we have present. Avoid susceptible and very susceptible varieties. Note that there's been quite a number of changes with regard to Septoria ratings in the Victorian Disease Guide, so make sure you go and get a copy of the Disease Guide, which is on the table in the next room. We collected data based on isolates from Victoria last year, which gives us the best information we've had for some time in terms of how Septoria performs in Victoria to our varieties. Septoria is a highly variable pathogen, so there's a lot of different strains out there, so it's very important to use regionally relevant data. Time of sowing is important. I mentioned earlier that the spores off the stubble are released early in the season. By delaying sowing, you can actually miss that early spore shower that happens in terms of spore release, and that can be an effective method of control. And I guess a part of that is thinking about the susceptibility of varieties that are being grown in which situation. And then fungicides, very important that fungicides are applied early in the disease development, not waiting until there's a lot of disease there. Fungicides don't give 100% control always, so it's really been proactive in Septoria management. So stubble-borne diseases. Now last year we saw a lot of issues with stubble-borne diseases, and typically we see more stubble-borne diseases coming out of drier summers because we get reduced inoculum breakdown or reduced stubble breakdown, which means we get more disease carryover. So it's, in a way, it's in contrast to what we see with rust. Now, one of the things we see with these diseases is that often it's a 2-year-old stubble, particularly where there hasn't been as much breakdown. So considering not just what was in the paddock last year, but also 2 years ago in terms of the varieties that have been chosen to go into paddocks with infected stubble. One of the diseases we're starting to do a bit more work on is yellow leaf spot. Now, at this forum last year, I talked about some data that we'd collected with the Birchip Cropping Group, and that suggested that in a mallee environment, yellow leaf spot was probably reducing wheat yields in the order of 10 to 15%, but it was an area that we need to do some more work in, so we put some trials in the ground last year. And what we're looking at there was growing resistant and susceptible varieties. Now, when I'm talking resistant varieties, they're not completely resistant, but they're just in that more resistant group compared to the highly susceptible varieties. And we grew them in the presence of infected wheat stubble and the absence of inoculum as well. And if we looked at the mean level of infection within the susceptible varieties, which are the red ones, so the mean level in the presence of the inoculum was 17% infection, so that was growing in the wheat stubble, and that resulted in an 11% yield loss, where the intermediate varieties in blue, in the presence of wheat stubble, the mean level of infection was 3%, and the level of loss in those varieties was 5%. And at the second site, we had similar losses there. So the losses that we're seeing in susceptible varieties in the presence of wheat stubble is again in that order of 10 to 15%. And this is work that we're going to continue on so that we can get better information in terms of, well, how important is this disease, so that you can then make good management decisions around variety selection and paddock choice for management of yellow leaf spot. I've got a couple of slides presenting some of the work of Mark McLean, whose work focuses on our barley diseases. And this one here we're putting in just as an example of the importance of avoiding susceptible varieties where possible for disease control, in this case it's scald. The green bars are showing the level of scald that developed in a range of varieties with the rating shown there. Now hindmarsh, you'll see there's rated resistance with a hash. In terms of the stubble inoculum that we used, there was no virulence on hindmarsh in that source of inoculum. Now that's different to what is occurring in a lot of paddocks, because we are seeing a lot of virulence out there. So just because I've got hindmarsh there as being clean, more look at it as a resistant variety. We don't rate it as resistance in our disease guide anymore. But you can see the relative effects on yield. No yield loss where a resistant variety is grown, but where we've got susceptible and very susceptible varieties, yield loss is in the order of 15 to 20%. So variety selection is a very important part of our disease management strategy. The other thing he looked at was within a susceptible variety, looking at a range of fungicide applications or strategies for scald control. And as you can see there, as you move down on the right-hand side, that there is a lot of strategies that are very effective at giving very good control of scald. But I'll talk through these treatments a bit more in terms of looking at yield, because that's where it really does get important. And what he's found in that work is that the best control was, in those cases, ignoring the one where we put multiple sprays out for complete control, the one on the very right, is that where there was an early application either through an early spray or a fertiliser treatment, followed up by a second spray at growth stage 39. Now, where there was a spray put out just at 39, there was reasonable control there, but not as good. It's very important to get that first control out before the disease really takes hold. And likewise, where there was early intervention but no follow-up, it provided an opportunity for that disease to take off again as the season progressed. But in the season at Horsham last year, the main thing we've found over a number of years is getting that disease control done early in the disease development, and then following up with a second spray if needed. The other one he's been doing some work with is net form of net blotch. Now, on the whole, we don't see a lot of net form of net blotch in Victoria, and that really relates to the varieties that we've been growing have good levels of resistance. But where we do see issues is where there are people growing varieties that are susceptible to this disease. So varieties susceptible have been grown, very important to make sure you're aware of just how damaging this disease can be. There are cases where this is nowhere near the level of yield loss that disease can cause in some seasons. But I guess the message here is that the best control was achieved again with a spray at 31 followed by 39. So those combinations of getting in early with the disease control and then following up to prevent further development of the disease, where single sprays at 31 or 39 weren't as good as the combination. Just going to finish on a couple of comments on cereal root diseases. On the whole, we've been seeing across Victoria increased reports of root diseases being an issue. So it's really important that you start to take notice of root disease issues, and if you're unsure whether a paddock's got an issue with root disease, Predictor B test is an ideal way of identifying paddocks before sowing, because levels have been increasing, particularly in paddocks that have got intensive cereal rotations. And I've got a couple of examples there just showing how there are good relationships between predictor B results and grain yield responses in Victoria. So we think predictor B is an ideal way of identifying risk prior to sowing. The other one, in terms of crown rot, there's been a lot of reports of people taking predictor B tests and getting a low test result back and then seeing significant amounts of crown rot develop in the paddock. The potential cause of that is where stubble is not included in the sample. Crown rot is a stubble-borne disease, and if stubble is not in the sample that goes to the lab for testing, it can't actually detect it. So it's very important that taking samples, you target rows, and if stubble ends up in that sample, put it in there. If there's no stubble in the bag and there's stubble in the paddock, grab some bits of stubble and put that in the sample, and that all gets mixed in together. Because what you're trying to do within a test like that is to identify the high level of risk. You're not trying to get a low result out of it. You really wanted to see, well, what risk is there in the paddock? So I guess in summary, rust pressure this year at this stage looks like it'll be quite similar to what it was last year, but we still need to be prepared to manage rust in the more susceptible varieties. Get a current version of the cereal disease guide. There's been changes particularly around stripe rust ratings and septoria ratings. If you're in the high rainfall area, really need to start thinking about how you're going to manage septoria, not just because of the loss that disease will cause, but also in terms of prolonging the use of the fungicides that you have available. Stubble-borne diseases are going to be of importance this year because of the reduced breakdown over summer. Now, when resistant cultivars are not an option, make sure you have a plan for fungicide use, and root diseases have increased importance and is going to need more monitoring going forward.